Well, welcome. My name is Patrick, and you are in what we call the Hotspot Theater. Let me begin today by saying a big thank you to everyone for coming out to Bishop Museum. We really do appreciate it. Now, this is the program we call Meet Me at the Hotspot, and in it, I'll explain what a hotspot is. You'll get to see and feel some of the rocks that ultimately come from these hotspots, and in the end, you get to see our own version of a lava flow. So I always like to begin by pointing out that we call this the hotspot, not because of this very hot and loud furnace behind me, but you're actually in a model of a volcano right now. And if you look at the top floor of this building, you see what is the vent or crater of the volcano. Just above us is the magma chamber, and we are down deep in the earth in what we call the hotspot. So this hotspot thing, what is it? Well, it's nothing more than an unusually hot concentration of magma. This is actually the term that geologists use to talk about this phenomenon. It's about 2,700 degrees, and of course that heat builds tremendous pressure. Eventually all of this breaks through the crust and forms what we know as a volcano. Now, you may have heard Hawaii is unique for a number of reasons. This is another one of them. There are only a few dozen hotspots in the world, and right now underneath the Big Island sits one of these hotspots. Now, the important thing to remember about the hotspot is that it has been stationary for millions of years. 70 million, 80 million, 90 million, we're not really sure, but for tens of millions of years, it has been in the same spot relative to the center of the Earth. So keep that in mind as we start to add on a little more about this. Now, I say it's deep within the Earth. Where am I talking about specifically? Well, right there between the upper and lower mantle. And when we think about the layers of the Earth, I like to think of it like an egg. So the core of the Earth would be like the yolk. The mantle of the Earth would be like the white. And then on the outside, just like an egg has a shell, our Earth has a shell. And we call that our crust. Now, this is an important part of all of this because this crust is broken into many pieces. And we call those pieces tectonic plates. And so as the globe spins around here, you will see us right there in the center of Hawaii, of the largest of these plates, the Pacific Plate. Interesting thing about these plates, they actually move. So the Pacific Plate is moving at a pace of around 5 centimeters every year in a northwestern direction. So 5 centimeters is maybe the length your fingernails would grow in the span of the year, so not very far. But if we start to put all of it together, we've got this hotspot pushing up this molten material. First it forms a volcano on the seafloor, but that grows to become an island. Well, over millions of years, as this Pacific Plate drifts, that island and the islands that form after it get slowly carried away, again in a northwestern direction. And then the end result is an island chain, which we now know as the Hawaiian archipelago. So let's take a look at this image here. When we talk about Hawaii, people generally think of the main 8 islands down here, but as you can see, we have a trail of this Pacific Plate's path as it has moved, and we have quite a few islands, 130 alone in the northwestern Hawaiian Islands. Now, all of those are very small and mostly uninhabited, except for a few scientists out there doing research, and a lot of seabirds and a lot of marine mammals. But the important thing to note from this image, if you look up here, those islands, the smaller ones, are actually the older islands. They've been around much longer. They've eroded. They've even sunken back down into the earth. And so by contrast, down here, the Big Island, Hawaii, is actually our youngest island. But this is a continuing process, and the story doesn't end right there. So let's take a look. We're going to zoom in here just off the southeastern coast of the Big Island. And you can see underwater, we have a volcano called Lo'ihi. Can you guys say that with me? Lo'ihi. So you can see it has a long, ridge-like shape. That is the Hawaiian term for long. So I actually have a piece of Lo'ihi here I'll pass around for you. This is something we call pillow basalt. When it first comes out deep underwater, it generally forms these very bulbous, pillow-like shapes, but it tends to be very unstable and breaks apart, so I have a broken piece of that pillow basalt there. You'll notice as this comes around, it's quite heavy. So this is a very dense stone. It forms deep underwater. Right now, Lo'ihi is about 15,000 feet off of the sea floor. It'll be another 3,000 feet before it breaks the surface of the water and becomes an island. And we estimate that'll take anywhere from 30,000 to 100,000 years before that happens. So no need to rush out and buy land just yet. I have another piece here I'll pass around the edges there. Now be careful if you are on the outer edges there. Please hold the stone back away so that we don't drop that and hurt anyone. Now, that's one of the few volcanoes we have here in the islands right now. Now, a little bit about the types of volcanoes we have in Hawaii. If you look here, this is a graphic showing what we call a shield volcano forming. So shield volcanoes form layer upon layer very, very slowly over time. And the result is a very gentle slope, a dome-like shape that they say looks like the curve of a warrior shield, hence the name. And then this is a wonderful example of a shield volcano. This is Mauna Loa on the Big Island. You can see that gentle slope, that dome shape. An interesting fact about Mauna Loa is it's actually over 13,000 feet high. In order to attain that height with this very slow, spread out process requires a lot of mass, essentially. And actually, Mauna Loa is the most massive volcano we have on planet Earth. Although recently they found something underwater they think might compete with this, but we're going with this for now. So. Now take a look here. If you're from this island, or if you're visiting, perhaps you've traveled around, and you might be wondering, well, where is that characteristic dome-shaped large shield volcano here on Oahu? Well, we've drained away the water, and you kind of see your clue here to the northeast. This is a large rubble pile, essentially, a debris field from a massive landslide that occurred. Our best guesstimate right now is that it happened around 600,000 years ago. But essentially, almost half of the shield volcano that made up this island and part of Molokai broke off and slid away into the ocean. So the end result you see here, this is a picture taken of the Ko'olau Range here on this island. This was taken from the windward side near the Pali Cliff area. And you see that very sharp, drastic angle? Well, that's where this mountain broke away and slid into the ocean. Now take a look at that image there. Who might that be? Yes, that is Pele, the goddess of fire. And legend has it that it is Pele who decides when our eruptions occur here. Some say she's been living in Kilauea since the mid-1980s when that first started erupting. And I wanted to give you a brief update on her most recent activity. So you may have heard on the Big Island, Hawaii, near the community of Pahoa, a lava flow has been advancing since around midsummer. And this is just a graphic showing just how close it has come to that community there. This is Pahoa Marketplace. The distance here is less than half a mile at this point, and this was actually, that image was uploaded on the 22nd. So it has gotten dangerously close, and we are certainly hoping for the best for that community there. Now, a little bit about the types of lava flow we get from Pele. The first of which is what people generally envision when they hear the word lava. A very fluid-like, smooth-flowing, often sort of slower-moving type of molten material. And this is something we call pa hoi hoi. Can you guys say that with me? Let's try that one. Pa hoi hoi. Excellent. So when this material cools, it leaves us with a very smooth surface stone that even sort of forms this ropey texture here as it folds over itself. I'll pass around a sample of that. And as it stalls and then advances again and stalls and advances, it forms these projections we call toes. So I have a little toe here. And again, that leaves us with a very smooth surface stone. Now that's in contrast to the other type of flow we have known as ah. Much easier to say. Try that one. Ah. So I like to describe this as, it almost looks as though it's heated coals or charcoals that are sort of rolling and tumbling as it moves downhill. This type of flow moves faster than pahoehoi. And when it cools down, it leaves us with this very sharp, angular stone. Now, a little joke we tell to help remember the difference between the two. Again, that pahoehoi is smooth. If you're walking on that barefoot, no problem. But if you step on it's ah. So put that in your head. That'll help you distinguish the difference. Now, those are materials that form from the lava moving over the land. Sometimes this lava gets ejected into the sky. It gets spat out of the volcano, and we call that spatter. And I'll send around a sample of that. And a few other types of material that get ejected from the vents or the crater of the volcano. This is something called scoria. And as this gets launched out, it has a lot of gas inside that as it escapes, when the stone cools in flight, it leaves this very porous, low-density stone. You'll definitely notice the difference between that and the pillow basalt I passed around earlier. And actually I have another here I'll pass around. Going even further that direction, this stone is actually less dense than water. It's actually volcanic glass called reticulite. And if you look at it very closely, it almost has this, almost like a honeycomb matrix formation to it. But again, it's lighter than water, so to speak, less dense, and it will float on water. We call that reticulite. Now, Pele's tears are what form when the lava gets launched, especially high into the air, sometimes thousands of feet, and it breaks into small bits. As those small pieces fall to the earth, they take on a teardrop shape, hence the name. And the lighting here in our theater is not the best, but you can see that teardrop shape there in the image. And then limu o pele. What does limu mean? For my locals. Yes, seaweed. So limu o pele is seaweed of Pele. And this material forms when the lava reaches the sea. So you have this hot molten material hitting cool seawater. Bubbles immediately form, and the surfaces of those bubbles cool down and leave us with this volcanic glass that is very thin and even has sort of a green hue to it. So I'll pass around a sample of that. Now it's very brittle, and it tends to break apart, but you can kind of see the pieces of it there. And then Pele's hair. This material we typically find higher in elevation, where the winds are stronger, and near the vent, where the wind picks up this molten material and stretches it out into thin strands. Those strands cool down and leave us with this volcanic glass that looks just like hair. And pass around a sample of that. Now, people often ask about the feel of this, and it's described as looking like cotton candy. In some ways, it's formed in that same method where you have molten, melted sugar crystals get stretched out. That's how you form cotton candy. Well, this is sort of the same principle here, but it's volcanic glass, so it is very brittle and needle-like, almost like fiberglass to the touch. And actually, let me just back up one there and show you. So you can kind of see that green color there in Pele's hair, and I mentioned it in the limu o Pele. That's the result of a mineral known as olivine. It's a crystal you can see inside this stone. I will pass it around with a flashlight so you can get a better look. And we find this in the material when it cools down at a slower rate. It allows these different elements to separate out and form these crystals. And so olivine, you may have actually heard of before. When it's found in its purest form, in gem quality, we refer to it as peridot or peridot. Sometimes you hear it pronounced both ways. And that's actually the birthstone for the month of August. Now, interestingly enough, on the Big Island, there's an area where there was a high concentration of this olivine that has eroded down, and it has left us with a green sand beach. So you may have heard of our black sand or red sand beaches. We have green sand beaches as well. So all of the samples that I've passed around are examples of materials that form naturally from the volcanoes here. I'll tell you a little bit about what we have going on behind me. This is a furnace that was originally designed for melting metals, specifically aluminum and copper. And instead of putting inside that metal, we have placed black cinder. So I'll sit around a sample here. Now this is a special kind of black cinder. We have to send a team far and wide to collect it, all the way over at Home Depot, just off of Nimitz. It really is that same type of material that we'd use in gardening around your home. But we placed it inside, and we heat it up to over 2,000 degrees. And after about 2 hours, it reaches a molten consistency that we can then pour out. And the product, when it cools, looks like this. This is something called tachylite. It's a type of volcanic glass, and it does form naturally. But this material here is very similar to obsidian, if you've ever seen or heard of that, in terms of its properties. It's very brittle, and when it breaks, it tends to leave sharp edges. So for that reason, I won't be able to pass it around. But if you want to get a closer look, please come on down afterwards. Now I'm going to step inside and pour out some tachylite for us. Before I go in, you'll see me put on this suit behind me. And this is simply an aluminized suit. It's got a thin layer of aluminum to help shield the heat. And this is very similar to what you would see a geologist or volcanologist use if they're moving out in the field near the vent or crater of a volcano. So if you have cameras and would like to get those ready, please go ahead.
Can you see that?
Yeah.
So as you can see along the edges there, it starts to darken fairly quickly. But again, that material comes out at around 2,000 degrees. So it takes a couple of hours before it's cooled down enough that we can touch it.
Wow.
Now as it cools, you'll start to hear it make noise. And what's happening is those particles are beginning to take up less space as they lose heat, essentially. And it starts to contract and pull apart. And eventually it'll shatter into smaller pieces. So again, we call that material tacky-light. And you do find it naturally. But I pointed out we started out with black cinder that we recycle actually throughout the period of about a week. And you take a look here, the material starts to take on different properties as you continue to recycle it. And I always point that out because people sometimes ask, is this just a physical change, like melting an ice cube down to water? Well, actually it's not. It's a chemical change. We are getting something chemically different in the end. We're burning off different elements and recombining new ones. Now, I like to end with a pop quiz. So take a look there at the material that I've poured out and think back to the two types of lava flow that I mentioned we have here, the ahoy hoy and the ah. Would you say that looks more similar to ahoy hoy or ah? What do you think? Well done, you guys are great listeners. So, yeah, it definitely has that smoother surface to it. So, now this concludes my portion of the program, but the star performer here will continue to snap, crackle, and pop. So I welcome you guys to stay back and watch that. Also, if you have any questions or if you didn't get a chance to see some of the samples, please come on down and I'd be happy to answer those and show you some of the samples. So, and I do want to say thank you again for coming out to Bishop Museum. We really do appreciate it. So thanks so much.